Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining this Neo4j live from, well, not really from, but talking about the AI Engineer World's Fair GraphRAG track. Andreas will be joining us shortly. He was or he is still at the event. I think it's continuing this week, and he was there all day yesterday. Here he is. Hello, ABK.
Good morning, Alex.
Hey, how are you doing?
I'm good. It's 8 a.m. here in sunny California, so sorry for being a little slow to get started. I do have some coffee already, so that was
Oh,
that was
good.
the critical thing before I joined. So I think I'm good to go.
Yeah, it's good. I just welcomed everybody and said, okay, we are talking today a little bit about the AI Engineer World's Fair that's happening basically all week this week. And they had a GraphRAG track dedicated to the GraphRAG stack technology framework, however you want to call it, specifically around the topic. So I was wondering if and I also posted it in chat, if anybody is watching live is also already using Neo4j with GraphRAG, or is already building something with GraphRAG, or just GenAI in general. How's it looking? So that would be interesting to see if you have any experiences on your own. And it can be anything, right? I mean, you can just start to look at it. You can be building something. You maybe have a prototype, or maybe you have something in production. I mean, it would be nice to hear from you what you're doing with AI and potentially combined with GraphRAG as well.
Yeah,
But
and I
yeah,
have to say, like,
maybe yeah. Sorry.
yeah, like, if people are like, thinking about maybe adding comments, here, giving us some feedback, that'd be great. I'd love to hear from that as well. And while people are typing, I have to say, like, this is our second year at the AI Engineer World's Fair. It is also the second time they've had the fair, so we've been there from the beginning, which is great. And for
Yeah.
GraphRAG, I remember doing this last year, and we went in, and it was very early days for GraphRAG, but like that was all we wanted to talk about, and we didn't really know, like, okay, we want to talk about it. Do other people want to hear it? And the response was overwhelming. It was fantastic. Every session that we had was packed in, people lining the back, of the session, sitting on the floors, and all those kinds of things. And fast forward to this year, and we're like, okay, we still want to talk about GraphRAG because it's still foundational stuff. If you're doing any kind of Gen AI work, you still need to figure out how to do retrieval, no matter, even if you're doing multi-agent, any other things. But
Mm.
is it really still interesting to people that they want to come in? And so
Yeah.
far, like in the first day, absolutely still relevant. People are like, okay, we still are desperate to learn about this stuff. Except that I think people have also then expanded what they're trying to
Mm.
do. So it's GraphRAG plus agents plus memory plus eval, all the usual things. So I see in the comments here. Sweet, who was this first one?
Yeah, I'm seeing here a couple of comments. Antonio trying to learn as a newcomer. Peter also a new
Yeah.
or still learning. Antonio says, I would like to learn what can I get from GraphRAG, which I cannot get from RAG. So yeah,
Yeah.
I think that's one of the things we can totally discuss today. And I mean, the AI Engineer World's Fair, and I think Silicon Valley in particular, when I talk to colleagues, seems to be always a little bit more advanced versus,
Mm.
here in Europe, oftentimes we are lagging maybe a little bit behind. So I think specifically in the AI Engineers World's Fair, I think it makes sense that now GraphRAG is almost like, okay, that's yesterday's news.
Yeah.
We are doing the next new thing on AI. We are agentic memory, MCP, all of these things.
Mm.
But what I see here in chat, and I think also talking to people, I think the GraphRAG is also still relevant and quite quite new. So it is important to maybe discuss it some more and to see where it fits in and how to connect it with other things.
Yeah, and I think you're right. So I'd love to, I'll give my take on like how you respond to this. Antonio's question, I think, is of course a perfect one. It's like, okay, why is always the first thing you should ask. Like, okay,
Yeah.
it's neat, but is it really useful? Like, what do you do? Um, and this is my take on it. The way that I've been thinking about it for sure, is that with regular RAG, with just vector similarity based RAGs, when you say just RAG, that's usually what people mean is just you're doing vector similarity search. So you've got some unstructured data, you've done some chunking, you've added vector encoding for all the chunks. We're all familiar with that, I think, by now. And you can fetch things. And the observation I always make there is that it really is kind of just a lookup. And so if you know that there is an answer for what you're asking, and you just want to get what the answer is. So like, hey, how tall is ABK? How tall am I? Okay, how tall is ABK? That's a lookup. You can, rather than having to write some SQL query or a Cipher query to kind of go get that. Now it's a natural language query, and it's a vector similarity search to find the answer to that. That works really great. But for, I guess, true questions where you don't know the answer, like it's like the unknown unknowns,
Yeah.
vector similarity search doesn't help you, right? Because you don't necessarily know what to ask. And so you're going to ask something that you think you're trying to figure out. But if the way you ask the question isn't reflected in the available answers, you're not going to get the information you need out of just a similarity search, right? And that's the starting point for realizing, okay, this doesn't always work. It's, you're getting 60% success or like maybe 70%, but you can't
Mm.
like the remainder of like the questions that people are asking, it's not enough because people are asking now more researchy questions. You're doing more exploratory things. You've gone past the first day of like, okay, just, tell me how tall is ABK. That's a terrible question. I know. I should have a better example. But then once you realize that people don't know what to ask for, and we've all experienced this with just talking to GPT, that we have to, how we say things influences even just talking to the LLM, right? That the way
Yeah.
we phrase things influences how it responds. Like, hey, talk like Yoda, it will talk like Yoda. Does that change the actual responses or the value? It does also. It's not just that it talks like Yoda, it also then has kind of a Yoda perspective on things. But when you're doing investigative things, doing researchy things, and you don't know what you don't know, that's not very helpful. And what you get out of GraphRAG is that you still get like those kind of initial points of like, here's the closest thing that maybe is relevant to what you asked, but also because you've done another bit of processing after the chunking, you've turned it into a graph, and we can get into how that happens. You then can also like jump out just one layer or maybe two layers of relevance that may not be directly similar to the user's question, so the vector similarity, but actually because you've gone out and expanded the context a little bit, now you've actually got the relevant chunks. And now when you present that back to the LLM to present an answer, it's going to be more likely able to give you an answer that actually is in the unknown unknowns category rather than
Mm.
just a lookup. Okay, that was a bit long, but Antonio, did that make sense? You can type in the comments.
Yeah, I think that makes a lot of sense, and I think in particular with LLMs, if you say okay, you're directly chatting via ChatGPT or something, I mean, I think they now have all realized that the hallucinations are a good thing. So what it does, if you go and ask it a question, it gives you really an answer that is not hallucinating a lot, that is not adding a lot of things. It tries to map as close as possible, which then creates the issue of it, like Richard said, it gives you this one hop answer, and this is fine, but it doesn't give you more beyond that, because it is told to not hallucinate, not to come up with things, but in the end it doesn't also know where to go next and where to go beyond, and to grab this additional information to make it a richer, maybe a more contextualized answer, which is then you, like you said, you give it you only get back what you ask, but you don't get more information out of it. And if you don't know what's in there, you cannot ask a specific question, and then you get the answer is okay, right? I mean, it kind of matches what you wanted, but it doesn't give you more, and there could be more in your data which it just doesn't touch and doesn't look at it.
Absolutely, absolutely. And now I'm going to think back to like yesterday, one of the talks was from a guy named Tom Smoker from a company called Why How, which I just love. The name of the
Okay.
company is great. Tom was a genius, and his talk was about legal documents
Okay.
and what they do with their clients. So they don't have a product; they have kind of a service where they use GenAI and agents for actually building what is it, like kind of legal briefs to help inform lawyers about like particular case studies that they want to get into, not case studies, but like cases that they want to take on. And they
Mhm.
basically scrape the internet. They do, it's not a lightweight job. They go ahead and do basically custom scraping of the internet for things that might be relevant to the case. So they look through all the usual public things that are possible to go ahead and scrape on the internet, but through the lens of this particular legal view of like a court case that they're trying to prosecute. And along the way, all the information that they gather is scored for how relevant it is, and how
Mhm.
relevant it is not only to the original case, but also to the things that are relevant to the original case. And they accumulate this custom knowledge graph that is specifically tuned just to this one, thing that they're trying to get done. Okay, maybe that's a lot of work. You don't want to do this all the time, but like it really highlighted like you can go as general as you want to with the knowledge graphs, or have a very custom knowledge graph that is like fine-tuned. Okay, that's maybe the wrong word to use. It's not LLM type fine-tuned, but very refined and very focused information for just a particular topic. And they are having such great success with this. All the lawyers that are their clients love it, because at the end of the day, they then produce this brief or this summary of like, here's all the latest things that are happening. Here's things that are not actually in the courts yet, but that are happening, latest news that are relevant to this. And then they hand this all over to the lawyers, and it's like having the world's best paralegal who does all this research, turns it into a knowledge graph. And this is the clever part of their why how. They focus on the why you do this stuff. It's to produce this summary, but the how part is that they build a knowledge graph, and it's the knowledge graph
Mhm.
that lets them build the most relevant stuff that actually fits and lets a lawyer actually have conversations with it. Okay.
Yeah,
Oh, Tony,
I
you got
think
great questions here.
pretty good.
So
Yeah. No,
again,
I mean, let's continue with the question. I just wanted to say, I think
yeah,
in this case, it's uh, uh, another good example of why it makes a lot of sense to define things as much as possible, and to give to give an LLM or a tool like this the option to look into context and to look into beyond the mere one hop, but go beyond and check it
yeah,
out all the data. Because I I read the other day that even if you tell an LLM to not come up with things, but even in what you mentioned earlier sparked that thought again in my mind. It was okay, but you ask it a couple of questions. Out of all the questions you asked before, it kind of assumes a little bit of who you are
yes,
and
yes,
what kind of person you
yeah,
are, and this assumption will then drive the answers in a certain way. And
mhm,
looking at legal text particularly, but also research and other stuff, you don't want the LLM to decide what kind of answer or what kind
mhm,
of truth you want to get. You want to be as fact based as possible, and it just shouldn't be going in some kind of weird direction, which because it wants to please you somehow,
yeah,
and give you
yeah.
the answer that you might like.
I love that. That's a great observation. That's you're totally spot on. And like on the one hand, it is really impressive and often very good the way that LMs have like the reasoning abilities that they have now. They'll have the whole chain of thought going on. But if the early kind of directional uh you know investigation or thought is just a little off, it
Mm.
propagates. It gets a little more off and a little more off and a little more off. It can be just 1 degree off, but like over 10 steps now you're over here when you should have been over here, and it's gone off the rails, so to say. And I'm
Yeah.
going to tie this in actually to Antonio's question a little bit about like he's asking about like knowledge graph construction and like how do you do this stuff. Keeping this in mind actually ends up being important when you're constructing a knowledge graph, because at some point you could imagine, okay, I'm just going to ask the LLM, hey, here's
Mm.
go research this stuff and build me a knowledge graph that I'd like to. And I'll refer back to Tom Smoker at this point. Like, they don't do that. They don't just say kick off a 3 day research project with the LLM, let it just go see what it finds. They have a very methodical approach where they do the web scraping, and on a at a very granular level, they do allow the LLM to make decisions like how relevant is this? Give me a scoring for this thing. But it's at every single piece of information that gets scored relevant to the original goal. And so you're never further from like relevant to the original goal, rather than, okay, you've now gotten 10 steps down. Now you've propagated a misunderstanding 10 times. The error rate, or I guess the potential for error propagation, is much reduced, because now you're really constraining what the LLM is doing for things like investigation, like you're giving it much tighter controls over like what it's trying to accomplish.
Yeah. And because Antonio also asked, so if there are any methods to build, graphs from documents in an automated manner and to do a couple of these things, I just shared the link to our GenAI pages, the developer pages. You find a couple of good examples, and it's exactly what you just outlined. I mean, you can drop everything into an LLM and say, hey, create this for me. Might not work, but you can at least start there if you want to at least get something and see how it generally feels. But then you should probably give it a bit more of a guidance and set it up a little bit better in order to avoid all these stumbling blocks you might come across.
Yeah, and along the way there, so like the tooling that you're mentioning that we have right now, you're exactly right. Like that, if you go in and you just have some corpus of text, some set of documents that you don't know anything about. If you know nothing about it, then you can do a first pass with this tooling and let the LM just go wild. And that's pretty useful for starting to explore and understand what might be there. But then it really is an iterative process saying, okay, thanks for showing me everything. But then you yourself have to kind of go through and decide, okay, what's useful to me, what's not. And you slowly kind of add more and more constraints, you would say, saying, actually, don't look for everything in the world. I'm really interested in, people and coffee and, maybe other breakfast items that are on my mind right now. But then as you do that, then the LLM is learning, basically you're learning, you're going to then help the LLM learn that what you actually want to get out of these documents. And in some ways, this is the equivalent of like what all of us have always done that work with data is you really want to drive the schema of the data and the shape of the data by the user's questions. If you don't know what the user, or if you are the user, you first have to have some idea about what you want to do, and then that will decide what kind of schema, or in graphs we sometimes say ontologies, but like the shape of the graph will be determined by what your investigation is. So both the content but also the shape of it will end up being influenced by that. So you start with the toolings and you kind of iterate a bit, and then you get to down to something that you'd like.
Yeah, and I mean, I would say in rare cases, you would just start with a bunch of documents. You have no idea what's actually in those. You probably have already some kind of database running that has already some kind of structure, and that if you take that structure and give it as a ontology or as a guiding principle for the unstructured data you then load into your graph, and you construct it this way, it is much easier to map things from your unstructured data, from your documents, and from those files with the already existing structure of a graph coming from a bunch of CSV files, or maybe some kind of schema you have already, and then you connect those, and then it's not as random and it's not as completely go wild, but it will make a little bit more sense because it is already tied to what you have in your company, in your structure. And then that is probably a good way to start with this, and then go on and add more and make it yours.
Yeah, I love that. And people often like that. It's such an important point you're just making there, because we now, at Neo4j, we take this for granted, like that's the right way to think about things. It's unstructured data doesn't live in a vacuum. It lives within a business. It has some some sort of value already, but you maybe just haven't structured it yet. And we know that all for our customers, all of the most successful things is that you actually already have some idea of like what data should look like for business value, because you might probably already have some structured data lying around. Otherwise, I don't know how you could be a business in 2025 if you don't have some sort of databases already around. And using that to inform the unstructured data extraction, I think I love that. That's such an important thing. And so you end up with this unique thing, and I think graphs are particularly good at this. You end up with a data set that is a blend or a mix of both structured and unstructured data, all in the one same data source, and in a dynamic way as well. You can still allow for some variation. It doesn't have to be totally constrained by the structured data, but it can be all the messy beauty of the unstructured data, but connected to the kind of reliability of the structured data in the database as well, which is pretty awesome.
Yeah, no, that's cool. You already talked about one session from Tom from
Oh yeah.
yesterday.
Mm.
I was wondering any other insights, any interesting presentations from yesterday that you thought, okay, that was pretty interesting, pretty cool. Maybe also something as to your point at the beginning, is GraphRAG still where everybody talking about, or is something else now taking over a little bit, and or is
Yeah.
maybe a combination of the two, something that
I think it's of course definitely a combination of the two. But if I was going to pick out sort of three, I guess I'll say trends or themes for the overall throughout the entire conference. GraphRAG, of course, was very present there again, very very relevant. Um, you couldn't escape doing multi-agent. Multi-agent is very definitely like that's the top line item I think these days for everybody is first, okay, let's build a RAG system, and then okay, we'll have it be agentic. But as soon as you do agentic, you pretty much end up getting into multi-agent. It's almost unavoidable. And so a lot of topics were around discussing that. And very closely related to multi-agents was whenever you build those systems, you also do a lot of tool definitions. And so for tool definitions, that gets into then MCP. And so MCP was a big trend. Which I both understood, and if I have just a little side comment here, also find a little surprising because MCP is, okay, you could have one 20-minute session, and okay, here's what MCP is, and you've described it. And I don't know why we would need 10 sessions on MCP, except for the point that MCP is one of these protocols, and I totally get it, like it leaves a lot of gaps. And so it's like it is the beautiful kind of expression of like how being underdefined sometimes ends up being a really big advantage. Like, and so what's great about MCP is the threshold for actually having something that is an MCP tool is very low, but because it's easy to make an MCP tool, it's because they haven't defined a bunch of things like how do you do authorization? How does this work in a multi-agent system? How do you do shared memory? Like it has a string of like questions that are then asked after that, and that's what all the other sessions on MCP were like. Okay, how do you deal with the things that MCP does not specify? So that was kind of one of the other sub trends. And then also very agentic, of course, was what do you do with memory? And this brings it full circle all the way back around to graphs, of course, because if you're doing things with memory, it's very similar in some ways, maybe to RAG and RAG to GraphRAG transition, where like the initial thing people might do with memory is, okay, we're just going to save the text and just have the similarity fetch for the text. That's really, that falls down more quickly than in just a retrieval setting. Memory that is just vector similarity is actually less good because what ends up happening is things like, oh, I'm going to use my coffee again. Today I say I love coffee, but for tomorrow, for some reason, I'm like, oh, I'm done with coffee. I never want to have coffee again. Now, inside of the memory, you've got two things related to coffee that are in conflict. And this continues, right? Like there's all kinds of situations where you need to reconcile what for the experience of the environment and the statements from a user and multiple users, what is true, what is not true, that becomes even more critical. And again, it turns out that the best way to resolve all that, at least show the sequence of things and have them be interdependent, is to express that all in a knowledge graph. And so like we had folks from Cogni, a group called Cogni, which was fantastic. They talked about their approach to memory. We had Zep was there representing, also showing how they do memory. Both of them were using knowledge graphs. Mem0 recently released a research paper where they now are adding graph representations to their memory as well. So all of agentic memory also ended up being, again, a knowledge graph, which obviously to me was music to my ears. I'm like, yes, we're all coming around to like, graphs are the best way to kind of represent these things because it's a very interesting topic. And if I spend one more time on this, like there was a lunch and learn session that was on agentic memory, and went through doing an entire kind of survey and panel of a bunch of different memory implementations, including Zep and Cogni were there as well, and it was so cool to see all the different ways of thinking about memory. Because as soon as you start to say memory, of course, the cognitive sciences people show up and they're like, well, let me tell you about what memory is. And they have all of these ways, of course, like how our human memory works. And very, very usefully, they then kind of translate that to like, okay, well, here's what that would look like in software. And so it ends up being this really interesting blend of kind of proper engineering and science, sciencey stuff and computer sciencey stuff, but informed by cognitive science as well, which in some ways has always been around. Like people have always, you have that some notions about like short-term memory and long-term memory. Like, okay, I kind of understand what that means. But if you really know cognitive sciences, there's like multiple models of how you think about what memory is and what does it mean and how do you reconcile facts and all these things. Anyway, so it was an amazing session.
Yeah,
And
I remember
yeah,
I had Cogni join a couple of weeks or months ago now on the live stream to talk about this,
awesome.
memory. And the funny thing is that they said, well, it's sometimes it's good for also for software like humans to forget things and to which is a notion that it came completely out of the blue for me. Was like, okay, but why? Why would I obviously
Don't
I
you want
forget things,
perfect
obviously.
memory? Yeah,
Exactly, but
yeah.
why? I mean, if I tell a technology or a software, if I tell it this is what I want, and then it shouldn't be forgetting this in 2 days. It should
Yeah,
it should
it's important. I told you
yeah,
specifically. Yeah,
yes.
but
Yeah.
and then when it actually, so at the moment, I love that point. Like I've been using windsurf a lot, and recently, and for I guess for a while. And I had this experience where like its memory is not what I would love for it to be because it forgets things. Like it goes
Yeah.
through, it understands my project, and I tell it, no, I've got a Python project, but I'm using UV. So if you're going to run tests, I want you to do this. And I give it very specific instructions about how to run the tests and how to do things. And that's great for like the day I told it, it's great. The next day I'm doing stuff and suddenly I'm like, I just told you yesterday how the project is structured. Why have you forgotten? This is not very helpful.
Yeah. Yeah. That is. I mean, yeah, that has its downsides, has its upsides, I guess. I mean, to your point when you earlier made about, okay, today I like coffee, tomorrow I don't. It's like after a 5-course menu or something with all the bells and whistles and lots of alcohol maybe, and I said, oh, I'm not gonna have this anymore. I'm tomorrow I'm gonna work out. And then you wake up tomorrow and obviously you don't want to work out. So, because you changed your mind. It's funny if a piece of software also changes its mind. Say, well, today no, I don't want to do something else.
Yeah, that's right. That's right. That's awesome.
Yeah.
Oh,
Antonio asks if you could share the link to these sessions, but I don't think they are available yet, right? I mean,
no,
I
they're
don't know
not
if they
yet.
were. Yeah. Okay.
So
Do you know
everything has been
if
recorded
things?
though. Yeah,
Mhm,
so
okay.
I think just like last year, they're going to end up. So the entire conference has been recorded, and if you haven't gone out to it, the AI Engineers YouTube channel, basically like for months after the conference last year, and it'll happen again this year. They just go through every single every single session. They edit it down, they package it up, and turn it into a YouTube video. So all the sessions will eventually will hit there.
Cool. I have added the link to their YouTube channel in the chat. I also tagged them as part of the video description of this video. So you should be able to see those there whenever they will be available.
Cool. And I want to scroll back, make sure we haven't missed any other questions. Oh, that's right. I skipped over this. Antonio, thank you so much for these fantastic questions. So Antonio asks a little bit further back in the chat about, sorry, what is an ontology? And
Oh, yeah.
this is one of those terms that, inside of the graph space, it's always kind of bandied about. And of course, we should explain what it is because very reasonable.
Yeah.
Nobody should ever know what it is. You should never have to know what is an ontology. The simplest way to say what an ontology is that it is one way of saying graph schema. And we could just say graph schema, but for reasons, the same way that we have other particular words for data records, we call nodes and relationships. Within the terminology of kind of graphs, people talk about ontologies instead. Whenever you hear that word, do not think about philosophically. We've got epistemology and a phenomenology, and we have ontology. yes, there actually is that also. And so that's part of the influence. But here, just whenever you hear ontology in your head, just map that straight over to graph schema. That's what you need to think about.
Yeah, yeah, that's a good way of thinking of it. The other question well, not purposely, but we kind of skipped over comes from Quant.
Oh,
In terms of evaluation, I think what tools to use, anything. I mean,
yeah.
I remember Ben Lorica at Notes last year had spent a specific chunk of his keynote ahead of Notes saying, okay, yeah, everybody does something with AI, everybody wants to do something with AI, but nobody does any evaluation. The best bit you get is a Google sheet or something where you do some kind of evaluation, but it is really tricky. And I think he outlined a couple of tools that were upcoming and that are like also based on AI. So like an AI checks another AI to if everything makes
Mhm.
sense. I don't know. Did you see anything? Do you remember anything at the show that talked about evaluation?
That's a great point. I that was another kind of I'll say like theme. Like, okay, it's hard to have all major themes, but like eval constantly is there. And I'll think back actually before the conference. I remember Andrew Ng, who's from Stanford and he's
Mm-hmm.
one of the guys, one of the professors who like is very influential within machine learning and overall AI. And he had a recent session at another conference where he was talking about evals and evaluations and how he's continued to be surprised on how little people do it. It's like, I understand it might seem intimidating, but as soon as you're doing any kind of work with an LLM, you should really just start doing some evals as well. And it is very much the AI, Gen AI engineering, equivalent of like writing tests.
Yeah.
You can write a lot of code. And I know nobody likes to write tests. It's not really a lot of fun. But if you don't have tests, then it's easy to make changes and then have your code break in ways that you didn't expect because the tests aren't there to keep you kind of in bounds, so to say. And so Andrew was recommending that, like, don't try to do comprehensive eval straight away. It can be very intimidating. You don't know how to necessarily set it up or what to do. He says, like, pick a framework or write something, yourself. But if you don't feel comfortable doing that, pick a framework like Ragas is one of the more popular ones. And the
Mm-hmm.
simplest way to think about evals, and it's true in all the frameworks, they just have different ways of doing it. The simplest eval is given some input, what is the output that you expect? That's really what you're doing. And it's just like doing unit testing in regular software, where given some input, you make sure that after some processes happened, you have expectations or assumptions about what the value should be coming out of the process. Um, but you have a framework like Ragas, which you can start to use to like set up like, given some inputs, here's the outputs that should occur, run the system and see if that's actually true. And Andrew's advice here was spot on, of course. Don't try to be perfect up front. Just start with like your I guess maybe this is also similar to doing regular testing. We have sort of an intuitive sense of the right way to do tests. And so we write tests in the what I guess I would say is the we pin down what the golden path is. Like, we know the things that are going to work. So we don't actually test for the failure modes first, because we know what seem like the obvious things. Like, okay, when one plus, when one and one is turned into the adding function, two should come out. And like, it seems stupid to do, but like, okay, just do that, just to make sure that that still is true. Because even though it seems trivial, it's worth pinning down the obvious things before you try to figure out, okay, what are the boundary conditions and like, what should I be testing? When you, as a human, look at something that's in an AI system, do the human eval first, run the system, and you have some expectations in your head. If it doesn't turn out that way, then try to figure out, okay, what should I pin down in the eval to, okay, it's a failing test, write down the failing test, and then try to fix it, and then see that the test passes. So in computer science terms, it's very much, TDD, test-driven development in a way, but it's
Mm-hmm.
eval-driven development. So it's EDD, I suppose, or yeah. So the Ragas framework that Alex put into the chat here, you should definitely check that out. It's the easiest way to get started. It is the most popular evaluation framework. So that's a good place to start. And even internally at Neo4j, we keep thinking about, and this is where some of the I think the front edge of development and evals are right now. That really works kind of, I called it a unit test, but for most
Mhm.
systems, that is really an end-to-end test because it's a full run of like, given some user input, what is the output? In a multi-agent system, it gets a little trickier because you want to test the individual parts of the agents as well, but they need some,
Yeah.
what you'd call some scaffolding, and then also some kind of like, you got to mock up some things that like lead up to, okay, and then when we get here, given something else has happened, here's the thing I want to test. That's a lot harder to do. And so now there's a lot of different frameworks for doing multi-agent testing. And to be honest, I'm not familiar with them enough yet, but that's something that
Mm.
I know in the back of my head, that's in my personal backlog of things to figure out. It's like, okay, for multi-agent systems, how do I really want to have fine-tuned, very, very closely focused testing happen as well?
Yeah. Yeah, and I mean, I understand that it is not as fun as building something, and it's like testing. It's boring. Nobody really wants to do it. But I think particularly with an LLM, I mean, you can define it as much as you. I mean, probably there's a point of defining it more. But if you do something, and we had a workshop the other day here, and it's the same queries every time, but
Mm.
the answers are always just a little bit different, and it is the environment is kind of always the same, right? I mean, it is not changing. So we don't add new data, we don't change the queries, we don't change anything, but it is still bouncing it to an LLM, and the LLM comes back with something, and it always
Yeah.
differs a little bit. Sometimes, usually it is close enough. They say, okay, yeah, this is more or less the same. It's just a different way, type
Mm.
of saying something. But sometimes it goes completely in the other direction. And you think, okay, how's this coming from? And
Mm.
then it makes sense to have evaluation beforehand because you don't want to throw this at users. Yeah.
Yeah, that totally makes sense. And
Mm.
I guess then related to this a little bit. Oh no, this is a branch from the earlier. Somebody in the chat asks about this is back to the earlier part of the conversation before we got into the evals,
Mhm.
about having an LLM create a reasonable ontology and keep it up to date. The keeping up to date is a great point. That is one of the challenges, and one of the things that happens when you move from last year to this year, I guess I'll say, from previously
Mhm.
when we are doing just sort of chat oriented, what one shot runs through things, to like having multi-agent systems. We've also at the same time gone from data ingest pipeline, no, not a data ingest pipeline, just simply data preparation, create some data, and then actually go ahead and work with the data that you've created. And very definitely now, as soon as people start going into agents, it is no longer just a single directional pipeline. It is a continuous loop of data ingestion into a live system, taking feedback from the user, putting it back into what you've known. That's part of what memory does as
Yep.
well. It's not just reading from the context, it's also updating the context. And so the question here about, can an LLM both create a reasonable ontology or graph schema, that
Mhm.
mapping, and keep it up to date is spawn on, like, it's a challenge now to actually do that well. And I guess I will say that it's similar to what we talked about earlier for both the original creation and the update. Let's talk about them separately first. That in the original creation of an ontology from, let's say, unstructured data, um, an LLM can do a reasonable job, but you need to give it guidance. And there's two ways to give it guidance. One is what we've first talked about, is kind of as a human, if you go through and see what the kind of the schema that it is understood or tried to extract from the unstructured data. It's like, oh, I found people and coffee and little bookshelf things over there. Okay, fine, that's cool. But actually, I only really care about coffee and coffee production, let's say. And so you can, by giving it hints about the kind of schema, you can then kind of collaboratively kind of work through. Now, that seems a bit onerous in a way. And the other approach that's starting to emerge, which is, um, I guess I'll say, a little more like vibe coding, so a little less methodical, is giving just descriptions of what you're trying to do. And so you don't give it any kind of schema hints. It's more like when you go through with an image generation and you're like, hey, I'd love to see, a pelican riding a bicycle and
Mhm.
see what it does, right? And they say, okay, that's not quite right, change this part. And some of the models are better than others about having, iterating on an image. But now that's something that the behavior is there, that the LLM providers know that that's something they need to do. And so the systems that do that are getting better at it. The same can be true of working with like an ontology or a knowledge graph, where with well crafted agents that are doing the actual knowledge graph or the ontology kind of definition,
Mhm.
you just simply describe what you're trying to do and say, actually, a little less of this, a little bit more of that way. And you don't have to be very precise, but you treat it as an iterative process instead. And very importantly, in the kind of the flows that happen here with the human in the loop giving feedback, that the feedback gets basically injected into a prompt that the LLM uses to actually do some work. But this is what gets to the update part. Even in this process here, what happens is that you start with a baseline and you slowly mutate that baseline rather than whole cloth being from scratch generate something. And that ability to kind of do the iterative process through with a little bit of feedback, making changes to things in a structure that has been defined. So you give here's what's been defined, here's the changes that the feedback from the user, make those changes, and then present it back to the user. That ends up leading to this keeping up to date part of it, where it could still be a user that makes the updates. Or if you so choose, you could say, okay, I just want this to be adaptive to whatever input is coming in. And that would be
Mm.
very dependent on like what the context is, of course, if that's a reasonable thing to do.
Yeah.
And maybe actually, now that I think about it, tying this all the way back to like what people are doing with memory systems and knowledge graphs as memory, that's exactly what happens in memory, is that the memory is constantly being adapted to what the user cares about. And so it's not
Yep.
just what's in the memory, but also how it's shaped, ends up being an iterative process through just continually updating from what the user is doing. And so maybe the memory structures themselves are optimized for bookshelf items or for coffee and coffee production, based on kind of an iterative process like that.
Yeah. I mean, the very interesting piece about all of this is that we have the possibility to give this feedback loop as part of the actual application. So if you have a chat interface and you ask questions or something and you get an answer back, you can the basic thing you could implement is a thumbs up, thumbs down interface where you get an answer back and say, again, this was a really good answer, give it a thumbs up. And if you have thousands of users and they all give thumbs up to a certain question and answer correlation, then you can always say, okay, yeah, store this together, and this is a good pairing, or this is not a good pairing. So we should find something else, and this feedback is then validated and part of the memory of the whole graph, and you have but by doing this, and the more feedback you get, the more responses you have from users, the better in the end sense your outcome will be.
Yeah, totally. And so I just dropped another link into the channel here. Somebody had asked about the original paper for GraphRAG and if there's any updates for that paper. And here, I'm going to assume that you're referring to it was the Microsoft Research GraphRAG paper, where and I always have to take the time to say this. I love the Microsoft folks; they're awesome. GraphRAG is a term, of course, that was in use before that paper, but that's the paper that really made it more popular. Um,
Mm-hmm.
and their original paper was from local to global, using query-focused summarization for retrieval-augmented generation, GraphRAG. I can't remember the exact title, but I dropped in a link there that goes to a Hugging Face collection, of Hugging Face space, or collection of research papers where we've been kind of curating, looking through all the research papers, and as often as I can, I was going to say every week, but like as often as I can, whenever I come across new papers, I add it to that list. That list is pretty comprehensive, from including that paper that you'll find it there. If you look from local to global, that'll be the kind of the keyword search to look for that particular
Mm-hmm.
paper. But then also the updates to that paper and other related papers, both papers that are earlier that didn't use that term, but that are related to knowledge graphs and doing knowledge graph retrieval. Interesting things like planning on graphs, which means like using the graph actually as a reasoning structure for the LLM to actually navigate through to come up with research plans. And then also things like memory you get into there as well. Of course, I'm curating that set of papers, but I think it's a really great research. So any things that we find that are there, I highly recommend it.
Cool. Yeah, I think that's great. And if you see something, I mean, I'll send it over. I think there's also the link to this Discord server that that talks, where people interested in GraphRAG discuss things. You can obviously also use this video link on YouTube and add a link to a paper or something, and we can have a look at it and add it to the collection if we missed something.
Yeah,
Or
that'd
if
be
you're
great.
writing something, right? I mean, you're you could be just writing the next GraphRAG paper that goes on this list.
That's right. That's right. And one of the things I love about this list is that uniquely, I think, certainly for me, research papers have always been something that's, useful to me. I love, reading and finding out what people are looking into. But uniquely within this space, it is a peek into like what's coming up next.
Yeah.
That this is driven by research papers in a way that hasn't always been true before. Research papers usually are things that other researchers read, and maybe a kind of back-end engineering if they're trying to optimize distributed systems or something. Okay, then they read some paper from somebody at the University of Edinburgh, and that's all really amazing. But for everyday engineering, you don't really read those things. Not so within AI engineering. The research papers are a peek into like maybe 6 months into the future. Somebody's going to have a startup based on that, or it's going to be a new feature that's added to something that you're already doing. And to tie all that together, and I think the papers are already listed there. From multi-agent systems that are a very hot topic now at the AI Engineer World's Fair, and of course graphs as well. One of my favorite papers a little bit more recently is a paper called Karma, which I'm going to forget it's an acronym, of course, because everyone's doing acronyms these days, and I'm going to forget exactly what it is. But it's basically a multi-agent system for doing knowledge graph creation, and it uses the technique that I was mentioning earlier, where like the goal is like you have multiple agents, not because you want to have a bigger system, but because you've broken down the process of doing something. So in the Karma system, it's like, okay, if we want to do knowledge graph construction, we're going to have a bunch of agents that have very specific jobs, so that the agent does not get confused by a bunch of noise that's not important to what it's doing right now in this particular step of actually knowledge graph construction, for instance. So there'll be a very particular agent whose only job is to identify entities. And it's given some guidance that's specific to like, okay, look for these kinds of entities, but it has don't do anything else. Just find those entities. And okay, that's its job. It's only going to do that. But then there's another agent that will have the job of reconciling. Is that entity that was just pulled out the same as this other entity over there? And it doesn't know all the other noise in the context window. Its context is only just for that particular job. And by having agents, lots of agents with very focused context, each of the agents can then really do a better job at their particular part of the process. Now, knowledge graph construction, of course, lends itself very well to that, but turns out that for a lot of things, if you broaden out a bit for using agents in business processes that are well understood processes, when you get down to like that level of granularity, the agents are better at doing their bit of the work. Importantly, they're doing their bit of the work, not kind of open-endedly. It is very focused, but they have a very mechanical view of like, okay, here's a thing I've been given as input. I have a very specific output that I need to do. And that, constraint ends up lending itself to much better results.
Cool. I just posted a link in chat because Andrew asked if there are any recommendation on the graph memory feedback loop mentioned. I know that LLM as a judge by length views is one of those that could be, and it also uses ragas as evaluation part of it, and it kind of like works as a using an LLM basically as an additional loop. Say, okay, yeah, I got a positive feedback. I'm storing this positive feedback, getting that in. So that could be a a tool to look at. I don't know if you are aware of anything
Yeah, so
else,
you,
or if
you'd
you
want to
have
look at both
any repos you.
both Cogni and Zep have good papers that they've published on their use
Yeah.
of memory. For Zep, the open source project that they have that is the foundation of the Zep as a product is called Graffiti. Graph ET, of course, being clever. Those papers are worth looking at for sure. And there's a tangentially related paper called KAG, KAG for knowledge augmented generation, which also takes this idea of like having a kind of a live knowledge graph that gets improved by a feedback loop. I'm going to forget exactly how they phrase this, but like they have a little bit, everyone has their own, terminology for things. And they talk about this kind of almost classic, transition from like you just have data, then you have information, and then turns into knowledge, and knowledge leads into wisdom. So they kind of talk about the loop of like by having a feedback loop, that's how you get from just, I guess that's what turns the information all the way into knowledge and then around to the wisdom. It's the wisdom that is the ultimate goal, but the feedback loop is really what enriches the wisdom over time. And without the
Yeah.
feedback, that in their view, of course, it's not yet wise. I don't know if it's necessarily
Yeah.
unwise, but it's not wise. Yeah.
Yeah, we'll see until we have reached that goal. It'll take a little bit more time,
Yeah,
I think.
yeah, that's right. And each of those papers, you'll find those at that Hugging Face collection. They're all there in the mix. Um, yeah.
I added all the links into the video description. So if
Okay.
you are wondering where they are, if you go to the YouTube part of this broadcast, and you'll find them all in the description below.
Cool. 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 I'm actually going to go take a quick
Cool.
look at, because this is meant to be, so my original goal here, like from and Alex, I'm so glad to have my guest appearance here on Neo4j Live. I always love all the interviews and stuff here, so I'm like, oh, I get to be on Neo4j Live. I'm here like just in my hotel room because it's early in the morning, and like I didn't have access to actually get onto the conference yet because 8 o'clock was too early for them to let me in.
Yeah.
And so I want to give a shout out to Swix and everybody who's done AI engineers. It's an amazing conference. If you didn't get a chance to go there, do look for the YouTube videos. And I think it's worth try to even book in advance for next year. It's one of my favorite conferences in the world. I was going to look at my show notes, not my show notes, but my conference notes, I guess I'll say, for
Mhm.
other things I want to call out. And actually, this is also back to papers a little bit. One of the things that led, one of the talks that led off the GraphRAG track was from Mitesh Patel from NVIDIA. And we've been doing some collaborations with them on, RAG and GraphRAG, of course. And they gave a talk on hybrid RAG, which did two things. They kind of tried to
Mhm.
frame like, okay, it's not an either or, it's always a yes and for all of the different techniques. And I think
Mhm.
that's an important takeaway across all of the things that people are building. In any production system, it is never just do this one thing. It is always, okay, do this thing and do this thing and then add this. Start small, of course, and add things over time, but having a kind of a yes and attitude about all this stuff. Even though like when you read the research papers and they'll be like, okay, vector similarity is terrible or RAG is dead, now everything is this. People have to we do that too. We have to sensationalize, like, and draw contrast to things, but the honest reality is it's always a little bit of this and then you also do this, and it depends, and it's all the usual things, right? And his talk kind of brought some of that out. And then also, of course, because it was from NVIDIA, and I'm looking forward to some of this collaboration we're doing with them, they're looking at how you can use GPUs and how they can specifically have they have a little library called cuGraph. I'm not quite sure how to say it, but it's cuGraph, which is for doing GPU accelerated kind of graph work, things like, named entity recognition, and also knowledge graph triplet constructions and things. So we're going to do some more work with them. I'm looking forward to like our collaboration. We've already done some work on what's called spanning trees inside of a graph. And forgive me if like, okay, this is more inside baseball kind of, graph talk. So let me describe the spanning tree for a second. Possibly, and hopefully everybody's heard of like the idea of a shortest path. The idea of a shortest path within a graph is that, if you have a social network of people who know other people, and, Alex and I don't necessarily know each other directly, but we have friends and friends and friends who know each other. The shortest path would be the shortest number of hops between friends, between me and Alex. And that would be a shortest path calculation. But for everybody who is, here at the live stream, and maybe, out beyond as well, if we included everybody here inside of a graph, and we didn't want to just have point to point, how are two people related? What's the shortest path between them? But pick 3 people or 4 people and be like, okay, well, how are these 4 or 5 people, all related? What forms out of that kind of, and it's the same basic idea, just extended of a shortest path. You still start with all of the people, and you try to find the paths that connect all those people. And I'm trying to do this magically in the air here. Like if somehow we go from all out here and we connect in somewhere, you can imagine that by trying to find the paths that connect all of those people, what it ends up forming is that in the middle, there's basically an intersection, which looks like then like the top of a tree that then goes out to each of the places you started. So that's called a spanning tree. It ends up being the smallest part of the graph, or a subgraph of the overall graph, that connects points of interest. Now that's interesting for doing RAG or doing any kind of retrieval from a graph, because often there are questions that start with multiple chunks, and like maybe you've got those chunks because of similarity search, or maybe you got them because of geospatial, or however you got them. You then think, okay, how are all these things connected? You then calculate the spanning tree to figure out how these things are all connected. That gives you the most relevant information between all of those starting points. And then you provide all of that into the context and get an answer, and on you go. So that little tangent was all based on like the work we've been doing with NVIDIA. We did some work with them on showing how to do that in a very particular way. There's a great blog post with, I'm going to forget one of the engineers who's involved in their side, Rishi, I forget his last name now, and then Brian Shee from our side. So it's a she and a she, but different kinds of she's. And they've got a great blog post about that. We're going to continue this collaboration and see where it goes. I'm very excited about that.
Super. Now that sounds very exciting. That's cool. And yeah, I totally agree with what you said in the beginning, right? This hybrid approach or multifaceted approach is always making lots of sense. I mean, this was always our credo, right? I mean, when we didn't talk about AI, we talked about graph databases, obviously, and we said, okay, you will be still using your relational databases, but you will also be using a graph database together with it, and it just makes things better. And here it's the same. I mean, you might just use a traditional vector search approach, a vector RAG, and then maybe you add GraphRAG, and then maybe you add something else on top of it, and then you combine these all, and it's just becoming more and more relevant and more contextualized, and the results will just be more fitting to what you want to do and what you achieve in the end. So it is just very much depending on what you want to do and what your expectations are, and you add things and you combine things and then you build on top of that.
That's right. It's like if you're in programming languages and you're like, I'm going to deny the existence of other data structures. I'm only going to use lists. Like Lisp has, of course, shown that you can do that. And if you love Clojure and those, that whole family of languages, then that's not it's a reasonable way to do it. And we know as engineers we can take any basic concept and do anything we want with it. But then turns out it's nice to be able to have maps and that are actually a data structure and have all these other representations of things. Objects are actually kind of nice as first-class citizens, and you kind of go down that path and you use the right thing for the right purpose, and it always ends up being a blend of technologies. And that's true from on the coding level all the way out to a system view of building a full architected system.
Yep, absolutely. Cool. I think that brings us already to the end of of this episode. I wanted to use the opportunity to just obviously thank you very much, ABK, for giving us this little insight into what happened yesterday at the GraphRAG, or generally what happens this week at the AI Engineer Worlds Fair. Like you said, it's a great event. I mean, I like to go next year if I can, but it is really it's really good, and lots of nice Neo4j folks around. So if you are still planning to go, or if maybe you're going later, look out for people with Neo4j t-shirts and talk to them. They're nice. If you unlike me, like me, I guess, sitting here in Germany or somewhere else in Kanko, maybe you look forward to the next episode. The next session is going to happen on the 11th of June, where we talk about RushDB, which is a tool built on Neo4j, on exactly graph native tools for the AI era with Artemi. So I'm looking forward to the session with Artemi next week, and discuss more what you can build with Neo4j plus AI, and what you can achieve there. So that's happening next Tuesday, I think. Generally, on all of June, we have certification month. So if you are not yet a Neo4j certified professional, you want to become one, we give you a couple of cool sessions, interactive sessions to help you on your path. With a couple of AMAs, a Neo4j fundamentals workshop, some insights into how to pass the certification exam with Jennifer. So all of June, lots of nice sessions. Check out the community forums on community.neo4j.com to learn more here if you're interested in that. And notes call for papers is closing soon, so there's only 10 more days exactly until we close the call for papers. So if you want to share a interesting story around what you're doing with graphs with Neo4j, and maybe AI, maybe not AI, it doesn't have to be AI, but it can be. Share your story, submit your call for papers. That would be nice to see. And these are the other links: Graph Academy, Neo4j Aura free, and our community pages. So if you are interested in building something, learn more, check out these links and dive in. I think the most important link for the specific talk today is the link to the GenAI ecosystem. I'll share that one more time in the chat, because there I think you have everything in one place around what is out there: GraphRAG, MCP, and other important bits, some repos, some demo applications, so you can basically get started from there. And I see amazing talk. Thank you, Antonio. Thank you, Rui, for the feedback. Thank you, Bogdan, and Felix. Really cool to see your feedback. If you like this episode, give it a thumbs up. If you like generally what we're doing here, subscribe to the YouTube channel. That helps out a lot. And if you have a story to share, I think Notes would be a great place to submit something.
Awesome.
Yeah. With that, I think we're ready to let you go. Thank you very much, ABK, one more time.
Thank you, Alex,
for being here today, and for giving us some insights from the cutting edge of AI development.
Awesome. This was a lot of fun. Bye, everybody.
Yeah. All right. Thank you.